So let's talk about spherical geometry. So as it sounds like, we're doing the geometry that is in a sphere. Okay, in a sphere. So before we get to a sphere, which is that three-dimensional figure, we'll talk about circles a little bit, which is two-dimensional of that shape, with arc length, area of a sector, and area of a segment. Now, arc length is part of the circumference. So an arc is a part of the circumference of a circle, which is part of the curve. Okay, so any 2 points, any 2 points can break the circle into arcs. We can have a minor arc, which is the shorter one, and a major arc, which is the longer one. So here I've got an example. So here is a minor arc because it's shorter than that major arc. You can see it's been broken by these 2 points located at A and B. And these lengths here go back to the center of the circle. Now, because they are the center of the circle, so any length from the center of the circle to the outside edge of the circle is, of course, the radius length, if you want to write that in. Yep. So both of those are the radius. So arc ACB, which is over here, ACB, subtends the angle AOB at the center of the circle. Okay, so that's this diagram here where we've got the point A and B there going back at the center of the circle, the radius R. Now at that point C, we say subtends, which is opposite that angle there, that angle AOB. Okay, that angle theta is angle AOB at that center of the circle. So this is telling us the fraction of the circumference that is the circle. We know that a circle is all the way around 360 degrees. That angle is telling us what part, how much, what fraction of the circle that arc actually makes up, what fraction of the circumference, I should say, that arc actually makes up. So we have our formula here. You can see a bit clearer there. S we think of as length of an arc, theta divided by 360 times by 2 times pi times r. Now that simplifies to pi r theta divided by 180. Okay, so that gives us the distance between 2 points on a circle using that curve. Okay, area of a sector. So a sector is a portion of the circle, okay? And we're talking here about a minor and major sector. You can see that the minor sector is the smaller portion compared to the larger sector. Now, it's important that you note that this sector has an angle at the center of the circle, okay? The sectors have these arms go off to the middle of the circle, to the center of the circle, all right? So that's what a sector is. And you can find that area of the sector, the fraction of the circle, the sector. Okay, I think I mangled things up a little bit there, but anyway. So area of the sector. So A for area equals what the angle is, theta divided by 360 times by pi r squared, which we usually just type in as pi r squared theta, all divided by 360. And that gives us the area of the sector we are talking about. So that's a minor area. That major area there would be 360, take away that angle there. Okay, let's do some past exam questions now. So this is a question 1, so from an exam 1, so it's meant to be straightforward. And this is from the 2017 Northern Hemisphere exam. A sector is cut from a circle of radius 12 millimeters. We can see in the diagram below. The angle at the point of the sector is 58 degrees. The area of the sector in square millimeters is closest to. Okay, so let's get up our calculator. And I'll look at my formula again. Okay, so pi times by r squared, and that was 12 squared, times by 58 degrees, all over 360. Now, I want a decimal answer, so I make sure I go Control Enter. Okay, 72.8849. So that will be closest to 73. Okay, the pie chart below shows the result of a survey. So you can see 20% disagree, 80% agree. Now this is a question 5 from 2020 exam 1. So that means it's about middle difficulty. Yep, 80%, 20% disagree. The radius of the pie chart is 16 millimeters. Okay, 16 millimeters. All right, the area of the sector representing agree in square millimeters is closest to. Okay, so agree is going to be 80% of that circle. Okay, 80% of that circle. So we know, well, what's 80% of 360 degrees? So 0.8 times by 360. So that means that the agree part is going to be 288 degrees. So now using our formula, we know, all right, so that's 288 times by pi, what's our formula again? Pi r squared, pi times by r squared, and that's 16 squared over 360. So that's 288 times by pi times by 16 squared divided by 360, approximately equal to 643.398. So that is closest to D. And 66% of the state answered correctly there. 14% of the state answered A. I think we can understand where they got that one from. Then so 8% was B, 8% C. Yeah, and then 1% no answer. Okay, now I could have, I think on my calculator, I could have gone 0.8 for 80% times by pi times by 16 squared. And yeah, I would have got the same answer there. So either calculation is correct as long as you understand what's going on there. So this is from the 2018 exam 1. This is the question 7. So that means it's going to be fairly difficult, or it's up there in terms of difficulty. A windscreen wiper blade can clean a large amount of windscreen glass as shown in the shaded area in the diagram below. So it's cleaning this part, okay? Not cleaning that part. The windscreen wiper blade is 30 centimetres long and is attached to a 9 centimetre long arm. So you can see that there. The arm and blade move back and forth in a circular arc with an angle of 110 degrees at a centre. Okay, so it moves like that. The area cleaned by this blade in square centimetres is closest to. Now the key here is recognising that we're only wanting that area, that shaded area. Okay, so for me, I look at this and go, well, I need to figure out the area of the whole thing and then take away that little area there. Okay, so the area of that big one is, we've got 110 degrees times by pi, and the radius here for this big one is 39 centimetres. Okay, divided by 360, 39 squared, isn't it? Okay, so 110 times by pi times by 39 squared over 360. All right, so 1460.06. Now, the smaller area that we're not cleaning, is here. It's this part here. And it is, X area, still 110 degrees, but now that radius is 9. Okay, over 360. 360. Okay, and all right, so 110 by pi by 9 squared over 360. Control equals. Okay, so that is 77.754. And what we want is the difference between those two. So I'll just arrow up, hit enter, take away that one, enter. So it's around 1382.3. So that makes it closest to B. And yes, 66 of the state answered that one correctly. So now we're going to talk about area of a segment. Now, a sector was when we had our circle and, you know, we had it like so with those arms going to the center of the circle. But here, our segment, you can see, is just a part of the circle. Those arms aren't going back to the middle of the circle. That leg, that line, is just straight between the 2 points. Okay, so we have here the minor segment, major segment. So how we get our formula is from this idea of a triangle. We're finding here that shaded area, So to find that shaded area, we find the area of the whole sector, then take away the area of that circle. Sorry, not of the circle, of the triangle there that has that angle here. So that's what we've done there. The area of the sector, take away the area of that triangle with its radius. Now it's being a bit simplified. Area equals r squared pi theta divided by 360 minus 1/2 sine, if you call that simplifying, but you know, I don't mind which version you use. So let's do one of these. So this is from the 2017 exam 1. So question 5. So again, that sort of middle difficulty is judged by the exam writers. So a segment is formed by an angle of 75 degrees. So you really have to read carefully whether they're saying segment or sector in a circle with radius of 112 millimeters. We can see it shown in the diagram below. So which one of these calculations will give the area of the shaded segment? Now, I hope you can look at this and straight away go, well, it's not A and it's not B. Why is it neither of those? Because they're not taking away, are they? When we look back at our formula, we have to take away that area of a triangle. Here, they've just found the area of the sector. Okay, so we're down to these 3 and let's have a closer look at them. So that is, we're looking at this area here, which is 75 degrees. So it can't be D because that's 285. All right, so let's look at these closer ones. All right, so is it over 180 or is it over 360? It's over 360, isn't it? And that's that one. That's the calculation we would use there. 81% of the state answered correctly. So 6% answered A, 6% answered D, 5% E, 2% B.